First of all, welcome. I'm very impressed by the numbers. We are flying over the 400 people, and it's not just Europe. I've seen people from Peru, Thailand, Colombia, Australia, Iran. So very impressive. I'm the director of the Copernicus Climate Change Service, and I want to welcome you to this series of seminar. And I was just thinking of spending a few minutes to introduce you to the program. So what we do within the Copernicus Climate Change Service and what is the role the climate projections play within it. If I can change the slide, yes. So Copernicus is the remote sensing program of the European Union. And as such, a lot of effort is put in the design of satellite mission, in the retrieval of satellite information, and so on. And this, the so-called space component. But alongside the space component, there is also a service component that is structured over 6 different services, from the air quality, atmospheric monitoring, to the marine, to the land, emergency security, and climate change. Climate change is the most junior, is the most recent of the service, but nevertheless is a service that has grown up and is already delivering, as you will see, a lot of information. Before going to the next slide and tell you more about the program, I just want to stress one element that is what is written here on the top, that the data and information that is provided by the program is full, free, and open to everyone for any sort of application. So that's that's very, very important. The Copernicus license allows any use of the data for any purposes. So if you want to simplify, the Copernicus Climate Change Service is something that is in between the observation, the collection of data, the modeling exercise, and the users. So we typically deal with big data in the sense of petabyte of data, and this can be satellite information, it can be model output from regional climate model, or it can be seasonal predictions. And on the other side, citizen, business, legislators typically require few kilobytes of information. And what we are trying to do is to simplify the transformation of this petabyte of data in this kilobyte of information in a way that makes sense. So that's our remit, excuse me. And central piece of this architecture is what we call the climate data store. That is a unique entry point to this, a huge wealth of data. So what do we do on this climate data store? Well, first of all, we have plenty of users. So we have 74,000 users and counting. And to each one of these users that are distributed, as you can see in the map, all over the world, we deliver daily something in the order of 80 terabytes of data. These are structured over 87 different data sets, and they keep increasing. So what is on the climate data store? First, there are observations, and these are, in this case, satellite-based observation, but they're also surface observation. And we use the concept of the essential climate variables as defined by GCAS to organize some of this information. So for all those ECVs, there are 22 in this long list, we have something to provide to the users. And this clearly is not something we do on our own. We do it in a very close coordination and interaction with a number of organizations all over Europe and all over the world who are providing this information to us, or who are making the necessary transformation so that the data can be easily accessible. But aside from the observation, by far the most popular product we have on our catalog are the Reanalysis. So this is the rerun of the weather prediction model over the historical period, and has recently been extended all the way back to the 1950s. It covers the world in 30 kilometers square, so 30 kilometer resolution, hourly time scale, and it goes from the 1950 to 5 days ago continuously. So this is an important entry point for anyone who wants to analyze their climate risk. And there are also versions at the regional level for Europe and the Arctic, and there are a higher resolution version for the land surface. And we use this information as a monitoring tool. So the combination of satellite information and reanalysis and other sources of information to monitor the climate. And we produce every month a monthly bulletin of the state of the climate. And at the end of the year, in April, typically, we produce a statement about the year that has passed, focusing on Europe specifically, and tracing back as much as possible to the ingredient, to the original data set that are available. But if you want to manage your climate risk, then you need to look forward. And looking forward means looking at climate predictions. So this is an example from our multi-model climate prediction system that looks 6 months into the future, and was output, in this case, the graphical output you see in the plot from last November, but also the numerical output are available for anyone to use. So hindcast and forecast are the seasonal predictions, and this is a global product. But clearly, if you want to go a step further and analyze how your climate risk is going to evolve over time, then you need to use the regional climate model, global climate model, a combination of the two. So what do we do within C3S is to provide access to CMWF5, CMWF6 simulation, but also CORDEX simulation for both Europe and for a number on non-European region. So we link up with CORDEX Core. We are working with the IPCC Climate Atlas to give continuity to Climate Atlas in between different cycles of the IPCC. And many of the new simulation will be made available on the CDS. Some of the simulation are already there, both CIM5 and EuroCordex are there, but there will be more coming, as you can see in this slide. But being operational is not just making the information available, the data available from the model, from the observation, is also to provide all that is around that data provision. So this is, for instance, quality assessment. For each data entry in the catalog, there is a quality assessment that looks at a number of different quality attributes of a data set. And this has been done in a way similar for all sources of data. So this being observation, reanalysis, seasonal prediction, or climate projection, all data entries have something that look a bit like that, which is a table that summarizes a number of quality attributes of that data set, which can be the uncertainty quantification, or the way in which the data set has been validated, or the intercomparison, or with other data sets. So this is another important aspect of being operational, as this program is. But it's not the only one. We are here today with a series of seminars that looks very popular, considering the number of attendees. And actually, we have a dedicated service for learning and training resources. Part of it is available online. There are the website here. There are MOOCs, so massive open online courses that we are running, and this is one of the areas where we want to expand and support further. So a number of links and concept here. I don't want to spend too much time, because today the effort is very much dedicated to the discussion of climate model, and in particular regional projection. So the last element I want to mention is the idea that it's not just data, it's also information about how the data can be used and manipulated and post-processed and transformed in this kilobyte of information I was talking at the beginning. So we have a specific part of the website where we collected a number of use cases, and these tend to be end-to-end services, so starting from the data all the way to a decision maker, a decision on the ground. And we have covered different sectors. I have here in the picture one that is quite recent about snow and the snow tourism on the Alps. There is a paper coming out very soon about that, in which the use of regional climate model has been extremely important to predict how snow resources will change in the future. So I don't want to take too much of your time, just to say that on the website there is a very important button on the top that is the user and feedback, user support. This is fundamental because it's yet another part of being operational, allows you to comment about what we are doing, provide your requirement, and allow us to modify the service